Welcome to MyProjectBazaar.com. Let we discuss about the process brain tumor segmentation based on hybrid clustering technique. Let us see the abstract of the process brain tumor segmentation based on hybrid clustering technique. Segmentation in medical images were more helpful in identification of the diseased portion in the input images. Preprocessing is the first step of the segmentation process. The images were filtered using median filter, which smoothens the overall image and makes the intensity all over the image normalized. Median filter is employed to smoothen the image and to filter unwanted pixels in the image. Median filter passes through the input image pixel by pixel, replacing each pixel with the median of the neighboring pixels, thereby providing normalized intensity in all over the image. The noises in the images were replaced by the above process. Skull regions captured along with the brain region in the images were different intensity and in larger in area. Skull regions were identified and they were removed based on morphological processing. Clustering process is then applied based on KIFCM clustering process. The regions in the images that were having similar intensity were clustered using KI fuzzy image algorithm. In fuzzy clustering, every point has the degree of belonging to clusters as in fuzzy logic rather than belonging completely to just one cluster. Thus, points on the edge of the cluster may be in the cluster to a lesser degree than points in the center of the cluster. An overview and a comparison of different fuzzy clustering algorithms uh, is done. Any point in the image has a set of coefficients giving the degree of being in the K cluster. With fuzzy C means the centroid of the cluster is the mean of all points weighted by their degree of belonging to the cluster. Each cluster region represents regions of different intensity. The skull regions were then removed from the images based on the morphological operations. Thresholding process is employed for the segmentation of the tumorous portions in the input image. The specific threshold for brain tumor portion is identified based on the identification of the maximum pixel of the input image. The image pixels that were having maximum intensity were identified to be the tumor portions. The threshold value is adjusted such that the value of threshold is 30 pixels lower than the maximum pixel. The image pixels that were greater than the threshold value were assigned the label 1 and the others were given value 0. The pixels that were having values 1 is the tumor portion in the input images and the others were the normal image portions. Level set segmentation process is employed for the segmentation of the tumorous portions in the input images. Level set segmentation process is employed by reducing the segmented portion till the curve closing the regions of the interest is obtained. The tumor portion obtained using the thresholding process is considered as the initial portion for the level set segmentation process. The image pixels surrounding the tumor pixels that have the similar values nearby the regions were grouped. Contours were extracted around the detected regions. The process is repeated till the boundary of the detected region is within the input region. The final result obtained is a segmented tumor portion. The performance of the process is measured based on the performance measures like true positives, false positives, true negatives, false negatives, accuracy, precision, and recall of the process. Let me see the flow of the process. The input MRI image is obtained from the dataset. The first step is the denoising step. Median filter is employed to smoothen the image and to filter the unwanted pixels in the images. Median filter passes through the input image pixel by pixel, replacing each pixel with the median of the neighboring pixels, thereby providing normalized intensity in overall image. The noises in the images were replaced by the above process. The next process is the skull removal process. The skull regions captured along with the brain regions in the images were different in intensity and larger in area. The skull regions were identified and removed based on the morphological operations. The morphological operations employed were open and close operations. The structuring element is a small binary image, that is a small matrix of the pixels with each with value of zeros or ones. The matrix dimensions specify the size of the structuring element. The patterns of ones and zeros specifies the shape of the structuring element. The closing of the image by a structuring element is a dilation followed by erosion. The opening of a structuring element is erosion reduction followed by a dilation process. After the removal of the skull, KFCM clustering process is employed. The regions in the images that were having similar intensity is clustered using KI fuzzy sequence algorithm. In fuzzy clustering, every point has a degree of belonging to the clusters, as in fuzzy logic, rather than belonging completely to just one cluster. Thus points on the edge of the cluster may be in the cluster to a lesser degree than the points in the center of the cluster. Any point in the image has a set of coefficients giving the degree of being the gate cluster. Each with fuzzy C means the center of the cluster is the mean of all the points weighted by the degree of belonging to the cluster. Each cluster region represents a region of different intensity. The next step is the thresholding process. The specific threshold for the brain tumor portion is identified based on the identification of the maximum pixel of the input image. The image pixels that were having maximum intensity were identified to be the tumor portions. The threshold value is adjusted such that the value of the threshold value is 30 pixels lower than the maximum pixel. The image pixels that were greater than the threshold value were assigned label 1 and the others were given label 0. The pixels that were having the value minus the tumor portion and the other regions were the normal image portions. Then the obtained threshold regions is then used for the level set segmentation process. Level set segmentation process is employed by reducing the segmented portion till the curve enclosing the region of interest is obtained. The tumor portion obtained from the thresholding process is considered as the initial portion of the segmentation process. The image pixels surrounding the tumor portion that were having similar values nearby the input image regions is were grouped. Contours were extracted around the detector region. The process is repeated till the boundary of the detector region is within the input region. The final result obtained in the segmentation is obtained by the segmented tumor portion. Finally, the performance of the process is measured in terms of the true positive values, true negative values, false positive values, false negative values, the area of the obtained tumor, the number of tumor pixels segmented were also measured. Let me see the running procedure of the process. If you want to run the code, select the file main.m which is present in the data source code folder. Right click it and click on run file. The user interface will be open for the execution of the process. First, select any one of the input video which is present in the dataset. So first we select any one of the input images which is present in the dataset. The image will be displayed in the axis. After that, media filtering process is applied to the input image. Then skull removal process is applied to the input the pre-processed image. Then FICM KFC aka FCM clustering process is employed, in which the input maximum unwanted regions in the skull removed portions were eliminated, resulting in the tumorous portions along with some unwanted portions available. Then we apply the threshold processing in order to remove the excess regions in the input images, obtaining the tumor portions alone. Then we perform level set segmentation process, in which the input seed regions were developed during the segmented tumor portion alone. So in the input image, this is segmented tumor portions. Finally, the performance of the process is measured in terms of the calculation of true positive value, true negative value, false positive value, false negative value, accuracy, precision, and recall, and the number of total pixels, number of white pixels, black pixels, then their ratio, overall pixel wise area of the tumor portion, they were all measured. Thus, we have segmented the tumor portions in the brain MRI images based on clustering techniques, thresholding techniques, and level set segmentation techniques, and we have measured the performance matrices for the process. The calculated performance matrices indicates that the proposed approach is more efficient compared to the other existing works.